I'm Ben Haslam, founder of the HumanAI Convention. The HumanAI Convention is a humble project to enable mass human flourishing through robust ethical training data. The hypothesis is that synthetic data AI scales on must be balanced with data from human lived experience and an ethical framework. Humans living their best lives provides the optimal data. That's the viability condition or convention that underlies this project. This proposal operationalizes that hypothesis through SimSat, a working prototype where the convention's 6 non-compensatory viability gates govern continual learning on a real-world problem. I chose satellite encounter triage because the constraints are physical: minutes between decisions, no round trip to ground, an uplink too small for weight updates, but large enough for compact operator labels. The architecture is the contribution. The satellite is the test case. One vision language tile encoder, Liquid AI's LFM 2.5 VL 450 million parameters, feeds a planner over encounter windows. A trust layer scores each candidate against geometry, priority, cloud, and visibility. 6 viability gates govern any continual learning that runs on top. We fine-tuned the LFM encoder with low-rank adapter on 165 operator-reviewed Sentinel-2 tiles. Base model exact action agreement on a balanced 32-row holdout was 0.156. Tuned 0.844. That was a plus 68.8 points. The score mean absolute error drops from 0.365 to 0.055, about a 31-point reduction in band-mapped prediction error. Per class accept and refine appear perfect. The adapter is now hosted on Hugging Face under an Apache 2.0 license. Rotterdam, 48.87% cloud cover. The scaffold says accept. Geometry is good. The trust layer disagrees, flips it to refine. The cloud might hide containers. The operator confirms accept. The visible 51% of the basin was operationally enough. This is the calibration loop. The same loop runs on every window. Vision language action or VLA layer test time training validated end-to-end. Stability first. 50 steps on the V3 adapter, 48 applied, 0 divergence. Parse rate 1.0 throughout. Then the headline result on 2 classes. 16 skip class encounters streamed. Skip lifted from 0.375 to 0.57, a plus 37 points. 16 defer class encounters streamed. Defer lifted from 125 to 0.875, which was plus 75 points. Average lift across 2 classes, plus 56 points in 16 steps. Test time tuning under operator curated stream empirically lifts target class accuracy per pass on 2 independent classes. The architectural claim validated on a real LFM check. We tried a few different ways to beat V3. More imbalanced data, minus 6.3. More class balanced data, minus 15.6. A different recipe, lower learning rate, longer schedule, more dropout, minus 3.1. 3 independent angles, same conclusion. V3 sits at a local optimum on this architecture in this holdout. That's empirical evidence for the runtime test time tuning lane, not just an architectural claim. All 3 negatives are published in the methodology documentation. On-orbit inference continually refined by operator labels within uplink bandwidth parameters. Apache 2.0 weights are on Hugging Face, public training kernels are on Kaggle, and the AGPL3 code is on GitHub. SimSat is built for an Orin 16 gig, which unlocks the long horizon adaptation we've already demonstrated